Csc102. I'm going to be taking you the next sections, study section 4 and 5. I'm Mrs. Adigun. So you're welcome to Csc102. I'll continue from where the other tutors stopped. And we are going to be treating computer programming. These are the outlines of what we are going to be talking about in this study section 4 before we move on to study section 5. We're going to be talking about principles of computer programming, and under that we'll talk about problem solving with computer. Then we'll talk about the techniques, also talk about programming stages. Then under the programming stages, we'll talk about definition of problems, we'll talk about the development of solution approach, writing instruction in programming language, converting them into machine sensible form, debugging the program, program testing, benefits of documenting your program. Then we'll go on to talk about the overview of programming languages, then types of programming languages. So these are the things we'll talk about in study section 4 before we move on to study section 5. And under this study section 4, expected to know the following. So these are the learning outcomes at the end of this study section. You should be able to state the fundamentals of computer programming. You should also be able to describe the steps involved in creating computer programs. Then you should also be able to give background knowledge of computer programming at the end of this section. So now let's move on to the first thing, principles of computer programming. What are the principles of computer programming? And the first thing we talk about under that is problem solving with computer. I know the first tutor would have dealt thoroughly with the introductory aspect of this course. So I'm only going to be building on what you have been taught before. Problem solving with computer. We all know that the computer is meant to solve problems. They are meant to solve different problems, various problems, depending on what you actually, the problem you actually want to solve as a user. So, and that's why we said computer is a multifunctional device with capacity of information processing. It's a multifunctional device because it has different functions that it can perform. And it has a great range of capabilities to perform all these functions. And these functions that it will perform depend on how you and I, the user, use the applications that have been embedded into this system, the application that has been installed into the memory. And I know you've talked about application programs. By now you know what application programs are. Application programs are the software that are created to turn the general purpose computer into a tool for a particular task, depending on what you as a user intend to achieve, what you intend to actually get out of the computer. So then when you writing a program that a computer can use to carry out or achieve its intended outcome is what we know as computer programming. We are going to talk about computer programming in details as we move on. And now let's move on to programming techniques. There are some things that we need to take note of for a good program. There are some things that must be in place for us to say, okay, this program is a good program. These are the various things that must be in place. And the first one is accuracy, reliability, efficiency, robustness, usability, maintainability. Then we have readability. Now let's take it one by one. When we say accuracy, what do we mean? Accuracy means that the program must be able to correctly perform that thing that it has been assigned to do. It must meet the laid down specifications, the particular criteria that has been set. It must meet that criteria and the specifications. So it must be able to do what it's supposed to do correctly. That is what we mean by accuracy. Then when we say reliability, the program must also be able to always do what it's supposed to do. It must be reliable. It must be, if you are saying, okay, this program will add 2 and 3 together and it will give us 5, it must be able to do it. That's why we said it must be able to do what it's supposed to do. That is reliability. Then when we say efficiency, the program must be able to use the available storage and space and other resources in such a way that system speed is not wasted. That is efficiency. Then we say robustness. What do we mean by that? The program should be able to cope with invalid data and not stop without an indication of the source of error. It must not just stop, it must not crash. The program should be able to cope with invalid data, and that is why you see that at times when, for instance, you go to an ATM machine and you're trying to insert your card, then you type in the wrong password, it will bring back a message back to you telling you the password is not correct. So at that point, that means it is robust. So the program should be able to cope with invalid data and not stop without an indication of the source of error, telling us the cause of the error. That is robustness. Then we have usability. The program must be easy enough to be used by anybody. Everybody should be able to use the program, and that's still using the example of the ATM machine. You can see that the ATM machine has been built in such a way that everyone that goes to it will be able to use it. They've not used big grammars that even an illiterate will not be able to use. Once you know that, okay, this is what I'm doing, I want to withdraw, this is what I should press. So the program must be easy enough to be used, and it must be well documented. That is usability. Then when we say maintainability, the program must be easy to amend, having good structuring and documentation. Maintenance, you must be able to maintain it from time to time. That is, if there needs to be updating, if there needs to be some things, corrections, you must be able to do it on that program. That's what we mean by maintainability. Then readability. What do we mean by readability? When we say readability means that the code of the program must be well laid out and explained out with comments. The code must be well laid out. That's what we mean by readability. And now we go to the programming stages. The programming stages, the preparation of a computer program involves series of procedures. It involves series of procedures. Before a program can be written, there are stages that it must have to pass through before you can actually have a program. And the first thing is the definition of a problem, the development of solution approach, the writing instruction in the programming language, converting them into machine sensible form, debugging the program testing, the testing process. Then we have the documentation. Now let's take it one by one. Let's talk about them. When we talk about program definition, before a programmer will write a program, before you can write a program, you must have an in-depth understanding of the problem that you are going to solve. Because don't forget, we said the computer is meant to solve a program. So for you to write a program so that the computer would solve a particular problem, you must have a good understanding of the problem. The programmer must have a good understanding of the problem that program would solve. So that's what we mean by problem definition. Then now the second one is development of a solution approach. What we mean by that is that at this stage, the programmer must have an algorithm that must be in place. Algorithm that is needed to be developed for the computer to follow in solving that problem that has been identified in the first stage. The programmer must have an algorithm. I know by now you should know what an algorithm is. You would have been told this. So algorithm are sets of instructions that are used to sequence of instructions that are used to solve a particular problem. So you have a procedure or an algorithm in place that has been designed for the problem you want to solve. Then the third stage is writing the instructions in the program language. The third stage involves writing that instruction that you want to design, you develop a first thing is that a flow chart will be developed from that algorithm. From that algorithm that you have designed, a flow chart is the pictorial representation of the problem that you want to solve. The pictorial representation is what we mean by flow chart. So you design a flow chart, then this instruction that you have written now is now transformed into a programming language, and you must have, for you to do this, you must have the proper understanding of the syntax of the type of programming language that you intend to use. As you move on in your course of study, you get to know the different programming languages that we have. So you must have a full understanding of the syntax that you want to use for this program, the syntax of the programming language that you want to use to solve that particular problem. Then the next stage is converting them into machine sensible form. The machine has a particular language that it understands. It has its own language that it understands. It doesn't understand this English that we speak, but it has its own language, and we call that machine language. So after you have written code, after the coding stage, it is now converted into the machine language, which are zeros and ones. They are the language that the computer understands. So the codes are now translated from the source program to what we call the object code. The source program is that code that you have written. So it is now translated to a machine language, which is the object code, and this is done by a translator. This is done by a translator. And we can also have an interpreter which accepts a program and executes it line by line. By the time you move on to the 200 level, you'll be talking of an interpreter, which is an example of the interpreter is the Perl language. Then you also have some languages that translate it at once. It would not execute it line by line. An example is Java. To translate it at once, it will read the whole program, the code that you have written, to read it at once and translate it. An example is Java. Then I've talked of in an interpreter would accept the program and execute it line by line. An example of such a program is Perl program, which you are going to do when you get to 200 level. And now, after converting them into machine sensible form, we have the debugging the program. The program will be debugged. There is no way you write a program at once, it will not have one particular error or the other. So when we say debugging, it means locating and correcting errors. So that is the next stage, debugging the program. It involves locating and correcting errors. Then after debugging the program, we have program testing. The program will be tested. At program testing, the program will be tested to ensure that it consistently produces the expected results. And at this stage, what you make use of is you make use of test data. Make use of test data, which you already know the outcome. So this is just done in order to be able to be sure that this machine would actually perform the process, what it has been intended to do. That is what happens. Then we move on to the program documentation. Documentation should be developed at every stage of the program, rather. By the time you are writing, after following all these stages, in the first stage, second, third, when you get to the last stage, you must have a program documentation. You must have documentation. And what are those things that should be present in the documentation? That's why we're talking about those things that should be included for documentation for each program. The first thing that should be there in the documentation is the problem definition step. The planning, second one is the planning, the solution step. The third is the program source coding sheet. And then the fourth is the user manual to aid the person who is not familiar with the program. Like you see in most electronics that we buy, notice that there's always a user manual. Then this is one of the documentations. It's just to show people that, okay, this is how you go about this appliance. The same way goes to program. A program, one of the things that must be included in the documentation is the user's manual. User's manual is needed. Then you have the operator's manual to assist computer operator. So these are the things that must be in the program documentation. Then now let's move on to what are the benefits of documenting your program. What are those benefits? So for the first one is that for everybody who interacts with the program, it offers all the required information. Somebody else, apart from the programmer, can just take the program. The person would be able to interact with the program, seeing the documentation. Then it also aids the supervisor in determining the program's goal. The person supervisor will be able to tell, oh, this is the program's goal. Then its usefulness, duration, and potential future revisions also. Then it makes program maintenance easier. You can be asked to update or revise some things in the program. So when the documentation is in place, it makes updating it easier. That's what we talk about. That's why we talk about makes the program maintenance easier. Then it makes maintaining programs easier. Okay, we've talked about that. Then it also instructs folks who are experienced with the application on how to utilize it. Then it gives the computer operator instructions on how to operate. These are the benefits of documenting your program. Then now let's move on to overview of programming languages. I'm going to be talking a bit about the overview of programming languages before we move on to the next thing. Basically speaking, we know that human beings cannot speak directly to a computer language. You cannot be speaking directly to a computer language and the computer will understand you. So there is a need for an intermediate language that the computer will be able to understand. And these intermediate languages are known as programming languages. They are known as programming languages. It allows a computer programmer to direct the activities of the computer. And even having a programming language, it doesn't stop there. These languages are structured around unique sets of rules. There are rules that must be followed. There are rules that need to be abided by. So these languages are structured around unique sets of rules that dictate exactly how a programmer should direct the computer to perform a specific task. We need these sets of rules because instructions cannot just be given in any form. There are ways that instructions would have to be given to the computer. And the rules of a particular language, of a particular programming language, would tell the programmer how the individual instructions must be structured, and it will also tell what sequence of words and symbols must be used to form an instruction. Like you can have the operation code, it will tell the computer what to do, such as add, subtract, multiply, and divide. Then when we have what we call the operands. The operand will tell the computer the data items that are involved in the operations. The operands in any instruction may consist of the actual data. It may consist of the actual data that will be used to perform an operation or the storage address of the data. Let's look at an example. An example is when we have A equals B plus 2. You know, we talk about the operation code, which can also be the operators. Then I also mentioned the operands. So in this example, A equals B plus 2, we can have the operation codes or the operators are the equals to, which is the assignments, then the plus sign, addition. They are the operators, or you say they are the operation codes. Then the operands, there are A, B, and 2. They are the operands. Then A and B are storage devices, while 2 is the actual data that we are working on. So this is an example of the rules we are talking about. So we move on to overview of computer programming in our next class. We are going to stop this class for today here. This is just an introductory part. So we'll move on to continue with the overview of computer programming in our next class.